Good morning, myself Riyada Chaudhary. My topic is offline signature authentication, a backpropagation neural network approach. My co-authors are Devajyoti Bonik and Akhilesh Panikrai. When we think about the field of information technology, security is the most important aspect. And when we talking about security, the most important three keywords are integrity, reliability, and authentication. Here we discuss about authentication. Authentication means we identify a person based on some unique characteristic. Generally, we divide authentication system in two ways. One is digital authentication and another is biometric authentication. Digital authentication means we identify a person based on some digital characteristic like PIN number or password or digital signature, etc. And biometric authentication means we identify a person based on some physiological and behavioral characteristic like voice, signature, fingerprint, thumb impression, iris, etc. Our topic is signature authentication. We try to authenticate a person based on signature, and here we used backpropagation algorithm. So these are the contents which we want to discuss one by one. Before we go for our technology or discuss our algorithm, we want to discuss about the related works or the previous works. Previously, many people try to authenticate a person based on a signature and they use different technology. Some of them are hidden markup model or HMM, support vector machine or SVM, receiver operating characteristic or ROC. Here in HMM, they use two databases. First database contains 40 signature of each 40%. That means 1600 signature. The second database contains 40 signature of each 60%. That means 2400 signature. In support vector machine, they use they only focus on the static characteristic of a signature. They does not focus on the dynamic characteristic, mean the speed or motion of the signature. When someone writes something or a person signed more than one time, the signature have some differences, and this difference is created because of the speed and motion of the writer. And the third technology is ROC. In ROC, they use our database contains 765 signature. So in the previous work, the drawbacks are, first drawback is big database, because when we use database of content 1600 signature or 2400 signature or 765 signature, that means it is a big database. When we use this type of big database, so it is time taking. That means our time complexity is increased, and our program may be complicated, or maybe for this purpose our output is not so good. So we try to reduce the database problem, big database problem. Next drawback is they always deal with static property. That means they does not focus on the speed and the motion of the writer. Previously I told that when someone write something or a person sign more than one time, their signature have some differences, and these differences is based on the speed and the motion of writing. And the most important and third drawback is success rate. Their success rate is maximum 96.5%, but our success rate is 99%. So these are the drawbacks of previous technology. Now our technology. Here we use a backpropagation algorithm. The backpropagation algorithm is under artificial neural network. So first we want to know what is artificial neural network. Actually, artificial neural network is a model of simplified model of biological neuron. Mean here we assume each node as a neuron, and each node is connected with another node, and this another connection have some dedicated path. Each path contains some individual value, and each and every time the network learns something from the environment and produce an output. There is two type of learning process. One is supervised learning and another is unsupervised learning. Supervised learning means we have already our target value, and the network produce another output, that is our predicted output. Each and every time we compare our predicted output with our target output, and this difference is called error value. So our backpropagation algorithm is under supervised learning process. And another learning process is unsupervised learning process. Unsupervised learning process means there is no target value, only the predicted output. Suppose there is no teacher present in a class and only students are present in the class and they try to learn itself. That is a unsupervised learning process. Now I explain backpropagation algorithm. Backpropagation algorithm is a layered architecture. So here is different layers. In a backpropagation algorithm, we need at least 3 layers. One input layer, one hidden layer, one output layer. Input layer is the outermost layer, output layer is the innermost layer, and hidden layer is between input and output layer. There may be multiple number of hidden layer, but there must be one input layer and one output layer. Each node of input layer is connected with each node of a hidden layer. This node is connected with each node of hidden layer. This node is connected with each node of a hidden layer, and this node is connected with each node of hidden layer. Same way, each node of hidden layer is also connected with each node of output layer. Now, the input layer receive input and process the input and produce a output. This output means the input layer output is input of hidden layer. This total process is calculated using linear activation function. Now, hidden layer take the output from input layer, and this is input of hidden layer. Hidden layer process this data and produce an output. That output is input of output layer. That means hidden layer output is input of output layer. This total process is happening using sigmoid function. Then our output layer produce an output. This is our predicted output, and this is under supervised learning. That's why already we have our target output. So now we compare our predicted output with target output, and this difference is called error. That means we calculate error. Now we propagate this error value to the towards input layer. That means we propagate the or push our error value from output to hidden to input layer. When we push the error value from output to hidden and hidden to input layer, each and every time the weights are adjusted. Initially, the weight is between 0.5 to minus 0.5, because it is proved if we draw a network for backpropagation algorithm, and if the initial weight of this network is between plus 0.5 to minus 0.5, the output is better than other value. So they push the error from output to hidden and hidden to input layer. Again, input layer do the previous process and produce the predicted output, and again calculate error. We do this process until the error rate is minimum, and this is backpropagation algorithm. Now we discuss our technology or our algorithm. Here is one original signature and 3 sample signature. Sample signature 1, sample signature 2, and sample signature 3. First we calculate the RGB and then the grayscale value of the original signature, and that is our target value. Now we draw a network for the backpropagation algorithm. This neural network contains 3 layers: one input layer, one hidden layer, and one output layer. First we take sample signature 1 and then calculate RGB value of the sample signature, and that RGB value put into the neural network, and that neural network produce an output. This is our predicted output, and already we have a target output. Now we compare the predicted output with the target output and produce our error. So now we use the backpropagation algorithm until the error is minimum, and when the error is minimum, we preserve the network value or weighted network as a final weighted network 1. Same way we took signature 2 and signature 3 and produce final final weighted network 2 and final weighted network 3. Now we calculate our average weighted network using final weighted network 1, final weighted network 2 and final weighted network 3 using normal average calculation formula. When we calculate the average weighted network, then we put the original signature through this network and produce a predicted value. That means here now we just use forward propagation algorithm and pass the original signatures RGB value through this final average weighted network and produce a predicted value. This is our final output, and this is our latest or upgraded predicted value. Now we compare this final output or this upgraded weighted value, predicted value with our target value. Now this target output and final output difference, if it is less than 0.5, that means the person is authenticated. If the difference between target value and our final output, mean the upgraded predicted output difference is less than more than 0.5, that means the person is not authenticated. Because we experiment that if a person's signature have some differences, but after that when we compare some authenticated person, when 1%, 2 or 3 or more than one signature, there have some differences, but that difference is not more than 0.5. But if the signature is not genuine or the signatures are forgery, then the difference is always more than 0.5. This is our flowchart. First we take the original signature and calculate the grayscale value of original signature, and that is our target output. Assume that target output is G2. Now we take sample signature and calculate the sample signature 1, calculate the pixel value RGB, and then the RGB value put into the neural network, and the neural network produce output. That is neural network first produce the final weighted network, and then using backpropagation algorithm, then we choose signature 2 and 3 and use same way we calculate final weighted network 2 and final weighted network 3. Now we calculate average weighted network. Now when we calculate average weighted network, we put the grayscale RGB value of our reference signature or original signature through this final average weighted network and produce an output that is called G3. So now our target output is G2 and our predicted or final output is G3. Now we compare this G2 with G3, compare G2 with G3, and after comparison, if our result or the difference is more than 0.5, that means the person is not authenticated. or if the difference is less than 0.5, that means the person is authenticated. So this is experimental result. This is our original signature. This is sample signature 1, sample signature 2 and sample signature 3. Now we compare original signature with sample signature 1. This is a screenshot. Actually we compare these 3 signature with sample signature, original signature, but here we just show only sample signature 1, comparison of sample signature 1 and sample original signature. This is experimental result. Mean this result is just for sample signature 1. After 7421 iteration of each pixel, the weighted matrix or weighted value of the neural network from input to hidden layer and hidden to output layer, we just show this value. This is a comparison table. Mean there is number of pixel value present in our signature, so we can't show all that pixel values. Just we show some of them, or here we show 4 of them: the pixel number, target output, predicted output, and the error term. Now the conclusion. In previous technology, the drawbacks are maybe they use a big database, or they only focus on static property, or their success rate is less, or maximum success rate is 96.5. So in our technology we try to reduce all of them, because here we use 3 number of signature of one particular person or one genuine person. There is some differences between one to another signature of a single person, and that is depend on the motion and speed of signature. That's why we calculate our average weighted matrix, because when we calculate average weighted matrix, that is the average difference of signature, one person's signature, and then we pass the original signature through that average weighted matrix, and then our average weighted network. So this way we try to reduce the database problem, and we focus on the dynamic property of signature, and after that our success rate is more than their success rate, because their maximum success rate is 96.5% and our success rate is 99%. One more thing is when someone writes something or some person sign, then the signature difference is based on speed and the motion and also the thinking of that person. So in future we try to authenticate signature, or try to implement or solve this problem based on the human thinking, or human their thinking in that time. So we try to solve this problem in future using genetic algorithm, and these are the references.